Salam and hello everyone. Here we're going to see how to derive the first parameter, d, and like I mentioned before, we are going to use a DEM-based data. Remember, in real-world cases, perhaps you need to go and take measurements of wells from the field, or go to a company or an agency that is in charge of water-related stuff in your country, or you could also contact or source data from published papers that have done similar work in your study area. Whichever way, once you have your data or is the same, perhaps if you're having point, just interpolate it and we are good to go. So here we're going to use the M-based data, and I have already created a project for what we are going to be doing. So as you can see, DRASTIC, and I already imported my area of interest. What I did was take a bunch of districts from the Ashanti region and just dissolve them to make one single AOI. So if you go to Ashanti and pick up the districts, you can see that. So you can see we pick these 3 districts and just put them together like that. So that's what we are going to be using for the entire project. Now, in my desktop, you can see I have created a folder dedicated to this entire project. Here we have all the data set that we're going to be using, from DEM to the soil data that's available. And I also have this folder with each and every parameter with its own folder. This way we'll be able to organize all of our files in the best way possible. So with this project open up, I'm just going to pick the depth to water data which we have here and put it onto the software. Now you see it ranges from 73 to 762, but since we are not interested in this whole region, we are going to clip our data out of the entirety of the Ashanti region. To perform the clip, go to Raster and then we locate extraction. Then you choose clip Raster by max layer. Now we're going to choose the depth to water for our inputs and then AOI for the max layer. I'm going to leave everything else to default and then just hit run. Remember, you can save it to file or temporarily before we get to save it. So you can see now we have a clipped version of the whole data, so we can get rid of this for the meantime. So now we have our minimum value to be 92, ranging to 588. Now what's next? So as we have this and we don't have any troubles with projection and any other pre-processing, what we have to do is reclassify this. Now we've already exhausted how to perform ranging, and then, but just as a reminder, if I come to check my histogram here, you can see how the data is spread all around. Now, a lot of papers will follow certain guidelines as to how to come up with the classes. But since we are using this data, you cannot conform to that norm. For example, if you look at this table here, see how depth to water in meters we having from 0 to 4.5 being a separate range, and we're having 30 as the max, and then all the way up. In our case, 30 is not even anywhere near our minimum value, so you can in fact never be able to use this at all. So we have to, or you, the analyst, have to look at your data and decide how you're going to do it, right? But then you just need to make sure it sounds reasonable. For example, in my case, I'm going to reclassify this into 5 different classes, right? What I'm simply going to do is cut it off from the beginning, or the minimum value, up to 150. And then the next class will be from 150 to 250 until we get to the end of it. Now that you know, let's go to processing toolbox. If you don't have it open here, just locate it here and open it up. Then we're simply going to search for reclassify, and you choose reclassify by table. And then when we open it, you see our clipped max is already here. So now we're going to make sure we click this ellipsis to open up this interface. And now we're going to add how many rows depending on what you have already decided to use here. Let's check this back in. So here I'm going to create 5 different rows. We get it here. Now we're going to input our minimum value for the first range and then our max value as well as the actual value. And this value here is going to represent our rates. Now the rate I mentioned earlier is from 1 to 10. So we get to rate features or distances that pose small threats. We rate them higher, like 10, and then we go down from there. Now, enough talking here, we're going to input, let's say 90 because our minimum here is 92. So putting 90 here, as long as it's less than or equal to this, we are good. And even depending on, let's go back one time, depending on the kind of equation you are using, you can have different way of doing this. So we are using value is greater than the minimum we are going to specify and less than or equal to the max. In other words, whatever range that we are going to specify, all those numbers should or must be greater than the minimum that we specify here. This is minimum. And then all of them must be less than or equal to the maximum, which is what we are going to put here. So like, for example, the 150 I was talking about. So now we're going to input 150 to 250 here. And then from 250 to 350, 350 to 450. And then from 450, if you say 550, you'll be having troubles. And why is that? If you put 550 here, remember this is now our overall max because that's our last class. And our overall actual max or maximum here is 588. So if you put 550 here, we'll actually be cutting off some of our data, which is not very good. And you get wrong results. So we want to make sure we have a number here that is equal to or more than this value here. So I'm just going to run it to 590 and that'll still be fine. So we're going to come over here and give it 10 to the shadow depth, which is 90 to 150 because that's more vulnerable. And then we descend like that and we give 2 here. And now we're fine. So from 90 to 150, 10 all the way down. So hit OK. Let's save this again to a file. I'm going to call this inside this folder. I'm going to label it DR. Hit save and run. Okay, now close this and see we have it here. Cannot get rid of this one. So now this is our DR. Now we can go ahead and modify this color and you can use that to now prepare your map for the D parameter. So now we have our DR here. Remember, what we can do is just multiply this by 5 to get your DRDW because 5 is the weight for depth to water. Or you can leave it this way and then once you're done with all of the parameters, you can do it all at one go in the Raster calculator. So the choice is with you, but I'm just going to do it that way. I'm going to multiply the weight, the actual weight or the standard weight, and then we know we have our DRDW or our overall depth to water done. So what I'm going to do is with DR, go to Raster and you open up Raster calculator. Now we have DR at 1. So just gonna take this, double click it, so we bring it into this area. And now we're going to multiply this by clicking on the star and the value 5. So this dr times 5. Okay, so now we're going to save this to a file inside D. So we just simply say dr dw. Basically, our D rated multiplied by the weight, which gives us drdw. Nothing to change here. You leave everything else to default. Just simply have to run this by hitting OK. Now we have these values now ranging from 10 to 50. This becomes our drdw. Now let's proceed to the other parameters in the other videos. See ya.